Okay, so we have seen the PDA for this language XC XR. This is the transition diagram for the PDA. So you are showing the transitions for the PDA. Okay, and this is one way to represent the transition. You mean that you are in the current state Q0 and you have the input A and stack top symbol is Z0, and you are modifying this Z0 with AZ0, means you are replacing Z0 with AZ0, and now A will be in the top of the stack. So, and Z0 will be in the next top to top. So this is one way. You can also construct the transition table for the PDA. So how you can construct the transition table? So for that, actually, you have to write move number. This is the way you can show the transition table. So you have some state, your machine takes some input, you have some top contents of your stack. On behalf of the three information, state, input, and stack symbol, your machine is going to make the move. So just you are numbering here. So this is the move number 1. So you are in the current state, initial state, you have the Q0. This is the current state you have. What is the input? Your input can be A. When your input is A, you can see this transition. When your input is A and your stack top symbol is Z0. So what you are going to do? You remain in the same state. So this is the move. You remain in the same state and you are modifying the top of the stack symbol Z0 with AZ0. So you have the AZ0. This is. You remember that this is not the content of your stack. This is just you are specifying that the top symbol Z0 is replaced with AZ0 and A is the top of this stack and Z0 will be the next top to top. So this is the move number 1, you can say. Now you can specify the other move. Move number 2, you are in the state Q0 and then your input is B and top of this symbol can be Z0, and you know that your machine remains in the same place and you are going to modify the Z0 with BZ0. You are pushing B onto the top of the stack. Now similarly you can say this is the move number 3 and you are in the current state Q0. Your input can be A and top of the symbol can be either A or B, you know that. So if it is A, then what is your job? Once you are at the state Q0, when your input is A, whenever you are at the Q0, you are going to save the input onto the stack. So just you are going to replace the top symbol A with double A and you remain in the same state. You are in the Q0 and you have the stack top is now AA. Finally, once you see, whenever you are at the Q1 and once you see that input exhaust, you can see whenever you are at the Q1 and you see that there is no input, you have the null and top is Z0, then you can transit to the state Q2. So when you are at the state Q1 and input is null and top is Z0. So when top is Z0, then you know that whatever you have pushed onto the stack from the state Q0, everything you have popped out. So top becomes again, effectively it becomes empty. That's why top is Z0. So once you are at the state Q1 and input is null, top is Z0, where you are going? This is the case of transition, changing the state, and you are moving to the state Q2, and we don't require to delete the top because top Z0, we believe that this is the initial contents of the stack. We don't require to delete it. Okay. So now from the Q1, whenever you see that input is null and top is Z0, then machine can go to the state Q2, and you know that Q2 is the final state. And whenever you reach to the final state Q2, what we believe that you have matched completely and nothing should be there. Your input is exhaust. That's why you can say that all other combinations or none. You don't have all other combinations. So you have only these combinations, means whenever you are at the Q1, you have the AA, then you delete it. Whenever you are at Q1, input is B and top is B. Again, your matching is done and delete it. And whenever you see that top becomes Z0, and you can make the null transition, and you are going to the state Q2 Z0. Once you move to the state Q2 Z0, this means that we have moved to the final state, and we believe that input exhaust. And if the input is valid, then it will happen. Now you have seen, this is the kind of the transition table you have made. And here you can see that every time machine is going to make only the single moves. So this is only one out. This is the unique place your machine goes. Every time you have only the one output for this. And machine is not required to make the guess at any place. Every place, at every state of the machine is able to make the clear-cut decisions. And this is, you can say that this machine deterministically, machine finds that what should be the move on behalf of the state, input, and stack symbol. So this is the one of the DPDA we have seen. So this is the deterministic PDA. This is the deterministic PDA. Even presence of the null transition, but this PDA is deterministic. Somebody can say that, okay, we have the input string X, which is, say, for example, A, B, C, and BA, and we need to verify whether this is in the, whether this belongs to the language or not. So how can you verify? You can start from the beginning. What is the beginning? At the beginning, you are in the state Q0. So you are at the state Q0 at the beginning, and what is the input you need to read? You have the input A, B, C, B, A. This is the input you are given. You are at the state Q0, and the input is given is A, B, C, B, A. And what is the current contents of your stack? You have the Z0. So this is the information you are having at the beginning. Once somebody gives you the input A, B, C, B, A, so you may want to verify whether for this input can your machine reach to the final state, or your machine is going to crash. So how can you verify like this? One way is to go for transition one by one, means you have to determine the situation like this. From this place, you have to move. You are going to move to the next transition. So what you can do? You are in the state Q0. According to the transition table, you can refer the transition table, or you can refer the transition diagram. This is the transition diagram. And either you can go for the transition diagram. So once somebody asks you to construct the PDA for some given language, this means you can construct the either transitions, you can go for the transition diagram, or you can construct the transition table. So this is the transition table of the PDA. So you can say this is the transition table. Okay. So there are two ways. Either you can go for the transition table, or you can construct the transition diagram. So you can refer the transition table or transition diagram, whatever you have constructed. So see that at the beginning, you are in the state, your machine starts from the Q0, and your input is A, B, C, B, A, Z0. You can refer the transition table or transition diagram and see what happened for this situation. Your machine is going to read the input one by one, and your machine is supposed to read the first A, then B, then like this. So you are at the state Q0, and your input is A, and top is Z0. Where your machine is going? Your machine is going to the same state, again in the same state A, Q0, but you have consumed the input A. So now remaining input to be read is what? B, C, B, A. And your contents of the stack is what? Your contents of the stack becomes A, Z0. So you have pushed A onto the stack. From this, now you can again see you are in the state Q0, your input you have to read is B, and top of the stack is what? A. So what you can do? So whenever you are at the state Q0, input is B and top is A. You can see the transition table. You are in the same state Q0. You have consumed the input B. Now the remaining input to be read is CBA. So this is the remaining input to be read. Okay, CBA, and A is replaced with what? Now B will become in the top of the stack. So you have now A is replaced with BA, and now this is the Z0. So this is the contents of the stack. Remember that in move we are going to denote the only top modification. We are not going to show the whole contents of the stack. Here actually you are going to say whole contents of the stack. Wherever you can find that these are not the whole contents, these are just the mode. You are saying that this A is replaced with BA. So you just show the top of the modification. You are saying that what top symbol can be replaced with which string. So this is the string by which you are going to replace the top symbol. But in the case of this situation, what you are saying that you have this was the top and you are replacing top with what? BA. This is the string. And you have at the bottom Z0. So B is Z0. This is the current contents of your stack. Now from this situation, you are going to make the moves, and you can denote by writing M, means you are making the move in the machine M, assuming that this is the machine M. So by making the further moves from this configuration, so you can say that you are going from this situation to, now you have the input C. Once your input is C and top is B, what you did? You don't save the input onto the stack, but read it, and you are going to the state. So you have this situation at Q0 and your input is C. So you don't require to save C onto the stack. You just read the input and don't change the top of the stack. Just move to the state, move to the state Q1. So here actually you are going from Q0 to, you are going to the Q1. Now remaining input to be read is BA, and what is the top of the case was B. You are not modifying the top is remains same, and you have the Z0. So this is the situation. Now from this place you are at Q1, you have to read the input B and top of the stack is B. What you did, you have deleted the top, means you are replacing the B with null string and remain in the same state. So you are in the state Q1. Remaining input to be read is, you have to read A next. Now the contents of the stack becomes, because B you have B and B is matched, B is deleted, and you have the now AZ0. This is the, from this you can say you are making the move, you are at the Q1 and you have the input A and top is also A, matching is done. So whenever you are at Q1, you see that here input is A and top is A, matching is done. You are just deleted, you have deleted A with null string. So you just say that, and you are remain in the same state, say Q1. Once you read it, the remaining input to be read next is what? Null. And you have deleted this because matching is done. The top stack contents becomes Z0. Then whenever you are at this situation, the next is from this you can move, your machine can move like this. So you are at the state Q1, remaining input to be read is null, nothing to read, input exhaust, and top of the stacks becomes now Z0. This means that whatever you have pushed onto the stack from the state Q0, everything you have popped out, and remaining input to be read is null and top becomes Z0. So you are moving to the final state, and this means you are going to the final state Q2, and You are at the final state Q2, remaining input to be read next is null, nothing to read next, and top of the, you are not going to deleting the contents of the stack. Top is again Z0. This is the initial stack content. So now you have moved to the this situation now. So what happened? Your machine is now at the Q2, and Q2 is what? This Q2 is in the final state. Q2 is the final state, means accepting state, and you have to read the input. There is nothing to read, and your top is Z0. So whatever be the contents of this stack, we don't worry. But what is the important we have? Your machine is moved to the state Q2, which is the final state, and nothing to read next means your input exhaust. So once you nothing to read next means your input exhaust, and your machine is going to move to the final state. Whatever be the contents of the stack, we don't mind. We can say that yes, this is the accepting configuration, and your machine is going to accept the string X, means yes. Answer is yes. Decision is yes, means X belongs to the language. You have identified now X belongs to the language, because for this input your machine moved to the state Q2 and successfully without crashing. So this is the situation where you have, this is the way you can prove one by one you can prove that yes, from the given input there is a way according to the transition of the machine, according to the move you have specified. Once you are going to apply the moves from the beginning, and you will go to the some final state when your input exhausts. So this now you can say that yes, the given input is in the language. So question is that what are these? Once you have specified the triple like this, what are these? Actually we are saying that this is the configuration of the machine. So machine is going to change from one configuration to the other configuration. So configuration of a PDA is what? The configuration of PDA of a PDA is triple. So we are going to denote the configuration of PDA like this. These are the configuration. So it is a triple. You have the three information in the form like this. You have the Q, this is 1, X, and you can see alpha. So this is the configuration of PDA. So you can say configuration of PDA is triple, where Q is what? Alpha, X, Q. Q is the state of your PDA, means your PDA is in some current state, which is known as the current state. So you can say you have the Q, and this Q is the current state of your machine. This is the current state, means Q belongs to the Q, and this is the current state. This is the current state of PDA. Okay, so Q is the current state, and what is X? What is X? X is the string which is taken from the sigma star, means this is the input string. So you can say that X is the string taken from the sigma star, and this is actually known as remaining unread input. Unread input. Okay. This is the remaining unread input. This means this is the if you are at the state Q, which is the current state of machine, you may say that okay, what are the strings you have to read next? Like whenever you are at the state Q1, if machine is at this configuration, then your remaining input to be read is only A. Whenever your machine is at the beginning and you have given A, B, C, B, A, this is the remaining input to be read. So remaining input, unread input, means machine has to read the input. Alpha is what? This alpha is taken from the set tau star, means tau is the symbol alphabet stack alphabet. So some strings from the tau star, which is the current, this is the current contents of stack. Okay, so alpha is the current contents of the stack. So this is the configuration. When you can specify the machine, means the particular state of your machine. How you can specify the particular state of your machine? By showing the configuration, means by telling that this is the present configuration of your machine, means you are saying that Q is the current state of your machine, and in this current state machine is supposed to read the input X next, means X is the remaining unread input, and alpha is the present contents of your stack, which is the current contents of the stack. And your machine is going to change from one configuration to the other configuration. Like for this example, you have seen that your machine start from this Q0, and for the given input this. When the contents of your stack is Z0, here this is the string which is in the tau star. Only you have the Z0. From this configuration, machine is going to make the moves. From this configuration, machine is going to make this move, and it goes to the next configuration, which is the Q0, BC, BA, and AZ0. Now, this says that now current state of your machine is Q0. Remaining input to be read is what? BC, BA, and the current contents of your stack is AZ0. This is the string which is stored in the stack. And as usual, once you say this is the current contents of the stack, then the leftmost symbol of this alpha is top, will be in the top of the stack. So leftmost symbol of the string alpha is corresponds to the top of the stack. So this means here you can say this A will be in the top of the stack, and Z0 will be in the next top to top. Here B will be in the top of the stack, A will be in the next top to top, and Z0 will be in the bottom. So this, if this is the leftmost symbol is B, and this is in the top. This is the top symbol. So leftmost symbol is corresponds to the top of the stack in the alpha. So you have seen that machine moves from one configuration to the other configuration. So you have seen machine at the beginning, machine starts from some configuration, and it is going to end with some configuration. So since the initial state of your PDA, we have the PDA, we have seen that let M is equal to Q sigma tau Q0, okay, next Z0 A delta. Okay, so for this machine, this is the current state, means this is the initial state of your machine, this is the initial stack contents. We can say at the beginning your machine is at the Q0. So whenever you are going to start, the configuration of your machine is like this. Your current state will become Q0, and you are given some input from the sigma. Here X belongs to sigma star. So you are taken the string from the sigma star, and you are supplying some input. And presently at the bottom of the stack, presently your stack contains only the symbol Z0. So this is the you can say that this is the smallest string. This is the string actually which is taken from the tau star. So Z0 is the current contents of the so this is what? This is the initial, this is known as the initial configuration. So this is the initial configuration. So this is the initial configuration of your PDA. This means at the beginning your machine has to start with this kind of configuration. What it shows? This says that Q0 is the current state, which is the initial state, and from this state you are given the input x. Since you are supplying the input x, means remaining input to read is x here, and this is the string at the beginning. This is the string stored onto the stack, means top of the stack is z0. So your machine can begins with this, and it goes from one configuration to the other configuration, and finally if x is in the language, then your machine start with this configuration, and then by making sequence of moves, PDA makes the sequence of moves, and it can go to the configuration like this. If it goes to the configuration Q, null, and alpha, where Q is what? Where Q, for some Q taken from the A, from the set A, and A is what? This is the set of accepting states. And if in this configuration, you know that what is the current state? Current state of your machine is Q. Remaining input to be read is null, means machine has reached to the final state because Q is in the A, and remaining input there is nothing to read next, and alpha is the current contents of your, alpha is some string from the tau star, and this is the current contents of your stack. So irrespective of the contents, we don't bother about the contents alpha. What is important, whether machine has reached to the final state or not. And once machine is at the final state, is there some input to be read? This configuration says that yes, nothing to read next. Machine is at the final state, and you don't have any further symbol, input symbol to read next. So irrespective of the contents of the alpha, we can say that yes, this is the final configuration. It means machine is able to reach final configuration. So this is the final configuration. Okay. So this is the final. Why it is the final configuration? Because machine has reached to the final state, and once it is at the final state, nothing to read next. And this is the important thing is what? Input. Once your input exhaust, whenever your input exhaust, you see the state of your machine. If it is the final state, then you can say that input is going to accepted by the machine, and hence this is the final configuration. So you see that starting from the initial state, if your machine is going to move to the final configuration, for which if and only if x is in the language. If x is in the language, if you can say if x belongs to the language represented accepted by the machine, then this will happen. So what is the language of machine? What is the language of the PDA? You can denote by writing this. Language of the machine of the PDA is given as set of x, which is taken from the sigma star, such that machine start from the initial configuration, and by making the sequence of moves in the it is able to move to the configuration Q, null, alpha, where Q belongs to A. So if this happens, means the language of machine can be denoted by the set of string x, which is taken from the sigma star, such that machine starts from the initial configuration, and by making the sequence of moves, it is able to reach to the final state. And when your machine is at this state and nothing to read, means everything it has read, means when input exhaust and machine is at the state Q, whatever be the contents of the alpha, we don't mind. We say that yes, machine reached to the final configuration. So if this happens, then you can say that x is accepted by the machine. So you can say that the language of machine is what? The language of machine is the set of x, set of string x, which is taken from the sigma star, such that x is accepted by the machine. And x is accepted by the machine means machine has to start from the initial configuration for the given input, and it must go to the final configuration. So this is the final configuration. Since we are accepting the strings by the final state, that's why this kind of acceptance is known as acceptance by the final state. Acceptance by the final state. Why it is so? Because we are accepting the information. Final state is important here. When your input exhaust, you have to see that what is the state of your machine. If the state of machine is final, then you can say that yes, it is accepted. So that's why this kind of acceptance is known as acceptance by the final state. Other kind of acceptance is also possible in case of PDA, which is, you can say, acceptance by the empty stack. Okay, so how it will be like this? You have the configuration like you are at the state Q, your input exhaust, and you have the this is the configuration which shows the acceptance by the empty state. Here state is not important. State empty stack. So state is not important. Q can be any element of the Q. Here there is no concept of the final state now. Once you see the acceptance by the empty stack, this means Q can be any state of the machine. Q can be any state. Okay. And what is important? Your input must exhaust. There should nothing to read, and your stack becomes empty. So once you see that input exhaust, you have to see whether stack becomes empty or not. If stack becomes empty and input exhaust, then you can say that yes, this is the acceptance condition, and your machine is going to accept the given input. So this is the different possible acceptance by the machine, which is known as acceptance by the empty stack. So in case of the PDA, you will see that there are two kinds of acceptance, like we have seen in earlier example. This is the acceptance by the final state because we have designated the final state, and we explicitly mentioned that the moves for which machine is going to for consuming the input, if X is in the language, then for such input your machine goes to the final state, and hence this is known as acceptance by the final state. Okay, PDA whose acceptance by the final state and the PDA whose acceptance by the empty state, both are equivalent. So there is very easy conversion. You can convert from one acceptance to the other acceptance. We will see next in this class how you can obtain the PDA from the acceptance by the final state to the acceptance by the empty stack, or if you have the PDA whose acceptance is by the empty stack, how you can obtain the equivalent PDA whose acceptance is by the final state.